Okay, so here's an example that will look very similar to AP style, AP free response questions that we might see on the actual exam. And what you'll notice is that they're going to ask you to interpret mathematical results in terms of the situation that is presented, so in context, with correct units and with a correct description. And they're going to ask you to make approximations. They're going to ask you to find exact values and extend your reasoning to other things kind of beyond that. So go ahead and copy this down. You might be able to cut out some of the prelim here, but copy down the questions and the table here. Go ahead and give this a try all the way through on your own. Really force yourself to pretend this is a real test and come up with an answer that you would be willing to submit on your AP test here. And then we'll take a look at it together. All right, this first one is pretty straightforward here. We're looking at the definite integral from 0 to 60 of a rate of change, right? And so we interpret that to be the total amount that that quantity has changed by. So since this rate measures the rate at which oil is being pumped, this integral is the amount of oil, or the quantity of the oil, that was pumped during that 60-minute or 1 hour period. So you'd probably get 1 point for having that correct. Part B is to correctly approximate this integral using a trapezoidal method. So here I've factored out the 5, which represents the base of each trapezoid, and I factored out the 1/2, which will be used to average the two side lengths of the trapezoid. And then on the inside, I just have each of the end side lengths are used only once, but each of the inner side lengths are used twice. You should remember that. And so this will be pretty easy to calculate. I'll end up with 3,582.5, and it's important that you have gallons here. That will be 1 point out of your solution. So it'll be, you might even get 3 points here, setting up your approximation correctly, and then having the correct value and the correct units, but at least 2 points. All right, next I'm going to write an expression with an integral that would give the average rate over the interval. And so I remember the average value of a function is 1 over b minus a times the integral from a to b of that particular function. And since the function I want to find the average of is the rate function, this will be 1 over 60 times the integral from 0 to 60 of r of t dt. Now, I've already approximated the value of this integral. So I'm going to be using my answer from part B here to make this a lot easier. And so this is where you can sort of see the building on top of it. Where you need to be efficient, you can utilize previous answers. So I'm only multiplying this value by 1 over 60, and that gives me approximately 59.708 gallons per minute. So that would be the average value of my rate, given this approximation that I've made using my trapezoidal method. All right, here you'd probably get 1 point for setting it up correctly, and then 1 point for getting the correct value with units. Probably be a combo. In part D, I want to approximate R prime, and they will do this a lot, where they will give you a rate and ask you for the rate at which that rate is changing. Think acceleration, right? The rate at which velocity is changing. And so I can approximate the rate of change using the average rate of change. So between 0 and 10, it's going to be the change in my rate divided by the change in t. So it'll be r of 10 minus r of 0 over 10 minus 0, and that's going to be 7 over 10, or 0.7 gallons per minute squared, because now I have gallons per minute, and so that's gallons per minute squared. I need to also use the approximation here, because this isn't the exact value of r prime of t. This is the approximation given by the average rate of change. And then similarly, between 50 and 60, I can follow the same procedure to get the approximation for the derivative of rate as 0.3 gallons per minute squared. So my guess is 1 point here, 1 point here. Maybe they give you an extra point somewhere in there for setting up your approximation correctly, but at the very least a couple of points. So hopefully that went well, and now that you're sort of beginning to feel really comfortable with this process, hopefully that'll make some of the AP pre-response questions seem a little more manageable. At this point, go ahead and head to the homework 7.10.